Okay, hello learners. In this video, we're going to look at question 5 from November 2017 question paper. This is a functions question, and it has a hyperbole, it has a log function, which is the inverse of exponential. So nice, good, grade 12 question, this one. Okay, let's jump right in. It says here, the diagram below shows the graphs of G, which is given by the equation 2 over x plus p plus q, and f, which is given by log base 3x. Okay, so that is my log graph, which looks like an exponential, but it's been turned sideways. And obviously this is my hyperbole. And then they tell me y is equal to -1 is the horizontal asymptote of g, which means I know the horizontal asymptote is q, right? So I already know that is -1 from this. Then b10 is the x-intercept of f. Okay, so -10 is the x-intercept of f. At T1 is a point of intersection between F and G. So there T1A, the point A, T1 is the point of intersection. The vertical asymptote of G intersects the x-axis at E, right, which I don't have information, and the horizontal asymptote at D, right. So okay. That's the point where the two asymptotes cut, and then this asymptote just cuts the x-axis there at that point. OB is equal to BE. This might actually help me some. OB is equal to BE. Oh, and since that's the point 1, you see from 0 to 1 and 1 to 2. So that's obviously then the point E is the point 2, 0, giving me that that is the line x is equal to 2, and this is the line y is equal to -1, which I know is the value of the p there. Okay. 5.1, write down the range of G. The range is all of the possible y values of the G, which is the hyperbole. The range of G, if you watch the video in general of functions already, then hopefully you should know that the range is always y is anything, but you must exclude the horizontal asymptote, obviously, because the y cannot go through -1 of a hyperbole, because there is an asymptote. The graph will not exist at -1 at the asymptote, but anything else, yes, that's fine. Okay, 5.2, determine the equation of G. Okay, so I need the P and the Q, which is, I already figured out here. Actually, the P value is going to be -2. The Q there is -1. I must just think quickly about this very carefully. You know, the equation is actually this form that they give here is wrong. It should be a over x minus b. They give here x plus b. So the equation should be standard x minus b plus q, right? Which, if the graph is x minus 2, then that means it's been moved forward. If it's forward, then the 2 is positive, or the p is positive, but then there is a negative. So for this to move to 2, that should be x minus 2. Now x plus p in this equation is going to make the p a -2 to have the result of the negative there. I actually want there to stand 2 over x minus 2 minus 1, like this, right? Now, since they gave me a plus here, the p is obviously -2, right? So p is -2 and q is -1. Okay, if they gave me a minus there, the p would just be 2, right? But since they gave me a plus there, the p is now going to be -2. Okay, 5.2, the equation of G, which is 2 over x minus 2 minus 1. There it is. Okay, 5.3, calculate the value of t. Now t lies on both graphs, so since I have the equation of g now, I can just substitute that point t1. A is the point t1 into this equation. Y is equal to 2 over x minus 2 minus 1. I can use that. Or you can use the log 3x because you have that equation as well. Right, so you can use either one. I think some of us might be more comfortable with working with an equation that we are familiar with since earlier years. So the y is 1 and the x is t. And then 1 plus 1 is 2 over 1 is equal to 2 over t minus 2. Cross multiply, I get 2t minus 2 is 2. Divide by 2, so t minus 2 is 1. And take over the 2, so t is 3. Alright, is the value of t. Or let me just show you alternatively what you could have done. Y is equal to log base 3 x, and if I substitute this in here, the y is 1 log 3, the x is t, just so you're not scared of the log function, right? Now I can't type log 3t in my calculator, but I can change this to exponential form using the definition of the log. So it's going to be 3 to the power of 1 is equal to t. So t is 3 to the power of 1, meaning t is 3. Using the log is actually shorter, but some of us might still be a bit scared of logs. Don't be scared of logs. They're really fun. They're really not that difficult. Make sure you know the basic definition of a log, how to change between log and exponential form. A lot of it you can do with your calculator. And there's a few log laws that's similar to the exponential laws. It's worth it just going through that so you can get comfortable with the logs. But logs really not that bad. Okay, question 5.4. Write down the equation of f minus 1, the inverse of f in the form y is equal to. So the f function is log 3x. The function f is log 3x, or y is equal to log 3x. Now to get the inverse function for any function, what you do is you swap the x and the y value. Right, so y becomes x and x becomes y, and then I want to rewrite this so that the y is alone again. Right, now just using the log definition, my base stays 3, but now my exponent is going to become x and the y is going to come that side, so y is 3 to the power of x, meaning that is my inverse function in the form y is equal to 3 to the power of x. That's not really difficult. Question 5.5. For which values of x will the inverse function be smaller or equal to 3? Alright. Now the inverse function, the function there, I actually want to look where the function has x3, which is at that t, right? So the function, the original function has the point 3,1 on it, right? So the function will have the point 1,3 that lies on the function, and they want to know for which values of x will this function be smaller than 3, right? Below 3, so x must be below 1. X must be below 1. Let me just put it on a sketch for you as well. The function is there, right, with the point 3,1 on it, right? So the inverse function reflection in the line y is equal to x will be there, an exponential function with the point 1,3 on it, right? And they want to know, this is the inverse function, right? So for which values of x is the inverse function smaller than 3? Now obviously this part is smaller, below 3, right? And that part is bigger than 3. For which values of x? Anything before 1. Okay, so anything before 1. 5.6 says Determine the point of intersection of the graphs of F and the axis of symmetry of G that has a negative gradient. What? Okay, the graph of F is this one, right? Okay, let me just put it in a picture for you first. The graph of F is this one, and the axis of symmetry of any hyperbole. Hopefully, this is not the x and y axis. These are my two asymptotes, right? Any hyperbole have two axes of symmetry. A 45-degree line that direction with a gradient 1, and a 45 degree that side with a gradient exactly -1. So those are the two through the point of the two asymptotes, not the x and y asymptotes, right? So this gradient 1 line, m is 1, and this gradient -1 line, 45 degrees. Those are the two axes of symmetry. So they want the axis of symmetry of G that has a negative gradient. So through that two asymptotes there at D, the negative gradient one is going to be this one with gradient -1, right? Determine the point of intersection between F and the axis of symmetry of G that has a negative. So they want this, well, cutting point between, it looks like it might be on that line, but not necessarily. I need to do the calculations, right? So this 45-degree line there through the point, this x is that point there, the x is 2 everywhere on that line at D, and on this line the y is always -1. So that at point D is the point 2, -1, right? So I need to get this line equation, this axis of symmetry, right? So this axis of symmetry has equation y is equal to m, which is -1x plus c, through the point 2, -1, which is the coordinates of the asymptotes, right? The asymptotes is through 2 and -1. And then I substitute that in there. Y is -1, x is 2, and that means that my c is 1. Okay, so this equation is y is equal to -x plus 1. Okay, so I want the point of intersection between this graph and the graph of f, which is log 3x. Right, so I basically want to do simultaneous equations between this. Okay. And I'm guessing the point 1, 0 will work. I must just double check because it seems like the point B will lie on that line and that line. I think that's the easiest thing to do, is actually just check if that works without now trying to make these two equal. And then how on earth do I solve log 3x is 1 minus x? How do I solve that? I think it's going to be easier to solve it visually. So it seems like that point will lie on both, and the easiest thing to do is just actually, before you jump in and do anything crazy, check whether the point B lies on both these. So B is the point 1, 0. If I substitute 1 in here, I do actually get 0. And if I substitute x1 in here, log base 3, 1, it's actually 0. So the point 1, 0 lies on both these graphs. B, the point 1, 0. Okay. The point of intersection is the point B, 1, 0. Right, and that is question 5. Fun. I'll see you in the next video for the next question. That's all of the functions questions from 2017 paper. So then we'll move to the 2018 question paper.